Hi guys, and this is Pranay, and today I'll be showing you my version of CS50's Intro to AI Project 4, the Nim game. So with Nim, we begin with some number of powers, each with some number of objects. Players take turns, and on a player's turn, the player removes any non-negative number of objects from any one non-empty pile. Whoever removes the last object is the loser. So there's some simple strategies that you may employ when you play this game. For example, if there's only one pile and just three objects left in it, and it's your turn, your best bet is to remove two of the objects, leaving your opponent with a third and final object to remove it. But of course, if there are more piles, this strategy may get considerably more complicated. So in this problem, I'm going to be building an AI which can learn the strategy for this game through a technique called reinforcement learning, by playing against itself repeatedly and learning from experiences. Eventually, our AI will learn what actions to take and which actions to avoid. So in particular, I'll be using Q learning for this project. So Q learning is when we use reward values, a number for every state action pair. An action that loses the game will have a reward of -1, while an action that results in the other player losing the game will have a reward of 1, and an action that results in the game continuing has an immediate reward of 0, but will also have some future reward. Okay, so let me try out my program. Let's type in python3 play.py. Okay. So we have a data set and testing for 10,000 times. So the AI plays against itself 10,000 times before, when it's done training, we can see the real visual representation of our game. So here we see the different piles that we have. We have pile 0, pile 1, pile 2, pile 3, almost stacked on top of each other, if you can imagine. So it seems like the AI has chosen to take one pile from pile 0. Maybe it can be a tactic. So let's go for pile 1, and let's take 2. Okay, so the AI chooses to take 1 from pile 1 this time. So what I would do as a player, I would take, let's say, 4. No, I mean pile 2, I'd take 4 counters. Okay, so the AI has left me with, of course, 1 counter left. So I'm guessing I lose, and it's game over. The winner is the AI. Let's try one more time. Once again, it trains against this dataset 10,000 times, and will learn from experience. So actually, it will get even stronger. This time the AI has chosen to take 3 from pile 1. Let me go for pile 0 and remove that 1 counter in there. Okay, so seems like the AI has done this. Let's go from pile 3 and take out, let's say, 2 counters. Okay, this could be a serious loss for us. 3 from here and 2 from there. Oh, okay. See, I'm guessing we're forced to choose pile 2 and 1. So the winner is the AI. I've still not been able to win against the AI, so I'm going to try one last time. So once again, training with experiences against itself. The AI, so it's my turn this time actually. So pile 1, let's take out 3 counters. Okay, so this program is very robust. Let's say we enter a wrong pile. Let's say we enter pile 9. And let's say we take out 2 counters from pile 9. The robust program will mean that it won't allow us to make that move. So if we try, for example, again, let's try pile 2, and then let's take out 78 counters or something ridiculous, then once again it's an invalid move. So just to show the robustness of this program. So let me do it properly. Pile 2, let's take out 5 counters. AI chose to take that, so I'm left with no option but to go for pile 0, and the winner is the AI once again. Clearly we can see how strong the AI has been tested, especially since it uses Q-learning. So the AI has developed from its experiences and knows what actions to take and what actions to avoid, and depending on that, the AI has been trained very well. Okay then, that's it for this video. Thank you very much for watching. I'll see you next time.